it is now time to learn how to solve proportions. To solve proportions, we utilize a method called cross multiplication. Some people also call that the cross product. There is another way of solving proportions, which I'll go over with you towards the end of this video, so stay tuned if you want an alternate approach. Let's jump into this. The first problem we have here is the proportion of x over 4 equals 8 over 16. Our goal is to find the value of x so that this indeed does become a proportion. So that means that we need to find the value of x so that the ratio of x over 4 is the same as the ratio of 8 over 16. Now, we could dive right into this and do some cross multiplication, multiplying 16 by x and 8 by 4, and solving the resulting equation. But the first thing I like to do is, I look at the fractions involved and see if I can simplify them. 8 over 16 simplifies really nicely, and that's going to make my solving much easier. 8 over 16 has a greatest common factor of 8. So I'm going to divide the numerator and denominator by 8. And that is going to make for a much nicer proportion. So I'm going to have x over 4 is equal to, 8 divided by 8 is 1, over 2. So now I've got a same ratio on the right side and a much easier proportion to solve. So simplify first if you can. Next, we're going to use cross multiplication. Cross multiplication, if you remember or have seen my earlier videos on it, does not change the truth of an equation. So we can use it. So I will multiply this and that term right there. 2 times x is what we get, followed by 4 times 1. So we're going to cross multiply that right there. And 4 times 1 is 4. And we're left with an equation that is very simple. We want to now solve 2x equals 4. So we're going to focus on that. How do we undo 2 times a number? We divide by it. So we divide both sides of this equation by 2. And we're left with the fact that the 2's divide out, and we have x equals 4 divided by 2, which is equal to 2. I think it's always worth checking your answer. So I'm going to do a little check off to the side right here. So this is our solution. But to see whether or not it's correct, we take 2 and we input it into the original ratio of x over 4. So that x now becomes 2, and then we get 1/2. On the other side. So the question is, are those two ratios equal? Well, there's 2 ways of doing this. Mentally, you can look at it and say, well, 2 over 4 is 1/2, so I know I'm right. But let's say that we're not sure if they're equal. You could either reduce this fraction to c by 2 on the numerator and denominator to see that you get 1/2, or you could cross multiply again. And our cross multiplication should yield true results. 2 times 2 is 4. 4 times 1 is 4. That proportion proves to be true, or I should say that the ratios prove to be equal so that we know we have a proportion. So our answer of x equals 2 is right. So I took that extra time there just to show you how to check your answer, as well as how to go through and use the cross product. Let's use the cross product again here on a slightly different kind of problem where you have the variable now on not only the right side of the equation, but, oh no, it's in the denominator. What do? The same thing we did in the last problem. We're going to cross multiply. Notice that 5 and 7 do not share a common factor other than 1, so I'm not going to reduce that fraction like we did the reduction of 8 over 16 in the previous problem. So I'm going to jump right into cross multiplication. 5 times h, like so, and then 7 times 10. And 7 times 10, we get 70. So what I'm doing here, I'll show out a little closer, is 7 times 10, and as I said, that'll give me 70. So now the resulting equation is 5h is equal to 70. How do I reduce that? Or solve it rather? I divide both sides by 5 to undo 5 times h. So I divide both sides by 5. 5 divided by 5 is 1. 70 divided by 5 is 14. And that is a funky looking h there, but trust me, it's an h. And that's our answer, 14. We're going to check our answer again, and I'm going to show you that you can either cross multiply in this previous problem like we did here, or we can reduce the resulting fraction. So we're checking to see whether or not 5/7 is indeed equal to 10 over 14. 14 being my answer. Well, what I'm going to do is actually reduce this fraction by dividing numerator and denominator by 2. When I do that, if I divide by 2 over 2, I get 10 divided by 2, 14 divided by 2. 10 divided by 2 is 5. 14 divided by 2 is 7. So what we have here is that both ratios are indeed equal. You could also have multiplied like this with cross multiplication and gotten 14 times 5 is 70, as well as 7 times 10, which is 70. That's another way to check it, as I showed it here. So it does not matter whether or not your variable is in the denominator or in the numerator, we can solve proportions with cross multiplication. Stay tuned for an extended peek in this video. I'm going to give you a little bonus coverage of how you can solve a proportion without cross multiplication. So if you're really good on the processes we just went over, great. No need to look at that second alternative unless A, you're curious, or B, maybe you had a little trouble with this and you want to see that alternative approach. My recommendation though, cross multiplication, learn it. It's a great tool. And now we're going to take a look at that alternative approach to using the cross multiplication method to solving a proportion. So that alternative approach works when you've got a variable over a number equals that fraction. So instead of using cross multiplication, if you choose, you can look at this as an equation where you have basically like m over 10 equals some number. So that's how I'm looking at that equation. So instead of doing cross multiplication, I'm thinking, how do I undo m divided by 10? Well, we undo division by 10 by multiplying by 10. So the alternative approach is really solving this equation like you've learned how in the past. So you'd get number times 10. Well, okay, so what does that mean in terms of what we're doing here? Well, the only difference is that number, I'll erase that, is 9/14. So we're going to multiply both sides of the equation by 10. And yeah, there happens to be a fraction there, but we can deal. The 10s divide out, and you're left with m is equal to 9/14 times 10, which we'll simplify now. I'm going to put that over 1. 10 and 14 share a GCF of 2. So the 10 will become 5 when divided by 2. The 14 will become 7 when divided by 2. Now we multiply across and we get 45 over 7, which as a mixed number is going to be 6 and 3/7. So this is just another approach to using, well, another approach instead of using cross multiplication. Again, I prefer cross multiplication. I think it's a one-size-fits-all approach, but I thought to show you this because every once in a while I use it, maybe if the numbers are a little nasty or if I don't mind the fraction on the right side. So take it or leave it, a different approach, and hey, who doesn't like a little bit of variety in their math?